the parameters which is involved and how to find this. Okay. So here what we have discussed is some mass of gas is taken, some amount of gas is taken and some heat is supplied. Okay. So when heat is supplied, the expansion of these gases takes place so that the piston will be moving. Okay. So here what are the parameters involved in this constant volume process and how to find out these parameters and what is this called as properties. Okay. So pressure is a property, volume is a property, temperature is a property, and then enthalpy, internal energy, entropy, all these are properties. Okay. From one state, when it is moving to another state in a process, the values will be changing. Okay. So for the constant volume process, initially we are going to we are having PV power T is equal to constant. Already we know that PV by P is pressure, volume, T is temperature is equal to constant. So this is the control which is already we have known. Okay. This can be applied for the process 1 and 2. This common formula can be applied for the process 1 and the state 1 and state 2. If it is applied for state 1, it is P1 V1 by T1 is equal to constant. The same formula is applied for the state 2. We can take P2 V2 by T2 is equal to constant. Okay, this is the common formula. It can be applied for the two states. So here right hand side is equal. Therefore left hand side is, we can make it as equal. So we are getting the formula P1 V1 by T1 is equal to P2 V2 by T2. Okay. So this is the formula we are getting. So this is a general gas equation which we are getting. Okay. By using this, if we know any 5 values, we can find out the other values. In a problem, if pressure P2, V1, T1 is given, P2 and T2 is given, if we don't know V2, we can find V2. So any values can be found by using this equation. Okay. Now I am applying this common equation. This equation is common for all the constant volume process, constant temperature, isochoric, isentropic, all the process. Okay. So now I am using this formula for this constant volume process. Okay. In constant volume process, what is constant? Volume. Volume is constant. That means here volume is constant. So what is the meaning is V1 is equal to V2. V1 is equal to V2. So here in this formula what happens is P1 V1 by T1 is equal to V2 by T2. Here V1 by V2 is constant, so it can get cancelled. So it is P1 by T1 is equal to P2 by T2. So this equation can be simplified for constant volume process like this and it can be used. Okay. Same way we have the real gas equations. PV is equal to MRT. P is pressure, V is volume, M is mass, R is gas constant, okay, and T is temperature. What is the value of R is 0.287. It's a constant value. Okay. All others can be varied. This equation also can be used. This equation can be used for state 1. It can be used for state 2. If it is used for state 1, it is T1 V1 is equal to MR T1 because these two are constant. Same way it can be used for second state. P2 V2 is equal to MR. Okay. So what is the purpose of using these gas equations is to find out the properties. This is the first formula which should be known for all the process to find out the values. Okay. Next is we are going for work done. Second one is work done. So what is the formula for work done is P into V2 minus V1. So pressure into V2 minus V1. This by using this formula we can find out the work done. Okay. Next, heat supply. Okay. heat supplied QS is mCV T2 minus T1. So this is the formula. Okay. Next we are having change in internal energy. Okay. What is it? Change in internal energy. Okay. So here it is del U. Change in internal. What is the meaning of del U is U2 minus U1. Okay. What is the formula is? Here it is same formula. mCV T2 minus T2. Okay. Lastly, we are having another formula. Change in enthalpy. Okay. Here change in enthalpy. What is the formula is? That is del H. Okay. That is H2 minus H1. This is the meaning. What is the formula is? mCp T2 minus T2. Okay. These are the total formulas which is used for constant volume process. Okay. So now here T2, T1, mass, all are will be given in the based on the conditions. Here CV is constant value. It is 0.718 kilojoules per kilogram. It is the value, and CP is 1.005. These are the two constant values. So now by using these formulas, we can find out all the properties from state 1 to state 4. We can find out what is the work done, what is the heat supplied, what is the change in internal energy, what is the change in enthalpy. Okay, and here the unit may be in kilojoules. Okay. Okay. So this is about our constant volume process. Thank you.